A free uranium-238 nucleus kept in a train emits an alpha particle. When the train is stationary, a nucleus decays and passenger measures that the separation between alpha particle and the recoiling nucleus becomes x at time t after the decay. If the decay takes place while the train is moving at a uniform velocity v, the distance between alpha particle and the recoiling nucleus at a time t after the decay as measured by the passenger is what? So let's find the answer. So uranium-238 nucleus kept in a train emits an alpha particle U-238. So this is uranium-238 kept in a train emits an alpha particle U-238 kept in a train emit an alpha particle. So this is helium-42. So this is U-238. So this is X-234. So that is 90, 234. This is helium. This is helium. U-238 kept in a train emits an alpha particle. So this is the alpha particle. When the train is stationary and nucleus decays. Train is stationary and nucleus decays. Passenger measures that the separation between the alpha particle and the recoiling nucleus becomes x at a time t after the decay. Passenger measures the separation between alpha particle and the recoiling nucleus. Alpha particle and the recoiling nucleus. So this is the alpha particle and the recoiling nucleus separation is x after the decay. If the decay takes place while the train is moving with uniform velocity v, so this is one instant. So when the train is stationary, so separation between alpha particle and recoiling nucleus is separation is x. In the second case, so this is the first scenario, this is the second scenario. If the decay takes place while the train is moving at a uniform velocity, so decay takes place while the train is moving at uniform velocity, the distance between alpha particle and the recoiling nucleus at a time t after the decay as measured by the passenger. So this is train moving with constant speed. As train moving with constant speed, so this is 234, 90, this is helium 42. This is alpha particle. So what happens in both the cases? In both the cases, so that comes under inertial frame of reference. So that comes under inertial frame of reference. So as that comes under inertial frame of reference, so no pseudo force acts on it. No pseudo force acts on it. So no pseudo force acts on it. So that comes under inertial frame of reference. As this comes under inertial frame of reference, no pseudo force acts on it. So in both the cases, distance covered remains same. So in both the cases, distance covered remains same. In both the cases, distance covered remains same. In both the cases, distance covered remains the same. In both the cases, distance covered remains the same. So that is x. In both the cases, distance covered remains the same. That is x. So option C is correct. So option C is correct. So option C is correct. So that is the answer.